Okay, so we've seen the basics of analyzing the sign of a polynomial. How do we handle factors that are a little bit different? What if, for example, one of our factors has multiplicity? Well, just look at the exponents, right? What happens if we take a power of a negative number? If we take an even power of a negative number, well, no matter what number we take an even power of, we either get a positive number or 0. So if the exponent is even, that factor is always positive or 0. On the other hand, if we take an odd power of a negative number, well, that doesn't change the sign at all. If the exponent is odd, that factor has the same sign as it would without the exponent. So, even powers are always either positive or 0. Odd powers, their sign is not affected. Okay, that's pretty easy. Let's try an example. So our first step is finding the cutoff points by setting each factor equal to 0. X equals 0, well, that's x equals 0. X minus 3 equals 0, that means x equals 3. And x plus 4 equals 0, that means x equals negative 4. So our cutoff points are negative 4, 0, and 3. Here x is 0, here x minus 3 is 0, and here x plus 4 is 0. So this x factor is negative to the left of 0 and positive to the right of 0. X minus 3 is squared. So wherever it's not 0, it's always positive because we're squaring it. But x plus 4 is taken to the third power, so its sign is not affected. It's negative when x is less than negative 4. It's positive whenever x is greater than negative 4. So our product is 0 at our 3 cutoff points. And then here we have 2 negatives, so the product is positive. Here we have 1 negative, so the product is negative. And then here and here, everything is positive. We want where the product is greater than or equal to 0. So we do want the points where the product equals 0. And then we want the points to the left of negative 4 and the ones between 0 and 3 and the ones to the right of 3. That's just negative infinity up to negative 4, including negative 4. And then there's a gap. And then we've got 0 up to, well, we just continue right through 3, just to infinity. Notice we didn't have to mention the 3, because the 3, we can just think of this as the entire ray to the right of 0, which makes our life a little bit easier. So that solution set ended up being a little bit weird, but there was really no change to our method of analysis. As long as we're going through with the analysis every time, multiplicity is not going to mess us up at all.